Hello, this lesson is on 4.2, the unit circle. And you might want to start by grabbing just a blank piece of paper and as best you can drawing a Cartesian plane on it, nice and big, and a circle. So get something like, I don't know, we all have Lysol wipes these days. Get a bottle of Lysol wipes and trace the bottom, and you'll get a nice big circle that you can work with. So the unit circle actually has an equation. We used to teach a unit in math where we looked at the equations of circles and other shapes. We don't do that anymore, but all you really need to know about a circle and the unit circle in particular is that it has this equation. X squared plus y squared equals 1. The 1 is the radius. What we mean by the unit circle is that the radius equals 1 unit. That 1 makes it really easy for us to create some ratios that I'm going to show you how we use in this lesson. So what happens in trigonometry, we did this in grade 11, is we take some kind of terminal arm out of the center of the Cartesian plane. We say that we've got some angle theta that we're working with, and then the unit circle is just the circle created by this point that would be anywhere along the outside of a circle. If I swung this blue line around, it would create this circle. Now, being that it's the unit circle, the 1 unit circle, the radius is 1. Now, I can drop a straight line down like this, and we can imagine here that we have a right angle triangle. Now, we know a lot about right angle triangles from grade 10 and 11. We know something called SOHCAHTOA that we've used a million times. That's going to come into play today. Now, I want to label the sides of this triangle. If I started at the center, at the origin, and I tried to plot this point, I would go over x units, and then I would go up y units. That's how we plot points in math, an x coordinate and a y coordinate, and they correspond to a horizontal movement and a vertical movement to get to that ordered pair. Now, if I do cosine of theta, now forget the circle, just look at it like it's a grade 10 SOHCAHTOA question. Cosine is adjacent over hypotenuse, adjacent, hypotenuse, opposite. Adjacent over hypotenuse is x over 1. Now we don't really need to write the 1 in the bottom. So we've just discovered that cosine theta is the x coordinate. Remember that we're talking about this point here. This is the point x comma y. That's how we plot it. But we just figured out that x is actually cosine. Where do you think we're going with y? If I use the hypotenuse of 1 and the y value, that's an opposite over hypotenuse. That's a sine theta. We just discovered that the y coordinate on the unit circle, if you've got an arm, a terminal arm of length 1, is going to be sine of your angle. That's really powerful stuff. That means that we can essentially memorize a whole bunch of values on the unit circle, and we can use them to evaluate trig ratios, which we're going to do in the next lesson. But first, we have to figure out what is this circle that everybody's memorizing. The circle comes from something called special triangles that you should have learned in Math 20-1. If you didn't learn them, here they are. And there's only 2 special triangles that we need to know about. And this is how they work. The first one is a 30, 60, 90 triangle. And the big thing to understand here is that 30 degrees is half as big as 60 degrees. So that's where the relationship in this triangle is going to come into play. Now, how they discovered the side lengths in this triangle can be explained. I recommend YouTubing it or reaching out to me for a deeper explanation. But the side lengths here are determined from an isosceles triangle. So if I were to take 30 degrees and do an opposite, hypotenuse, and adjacent, I would get these three trig ratios. Now, when you look at something like tan 30, you might be confused as to why tan 30 is not opposite over adjacent, like we know it is. But it actually is opposite over adjacent. We've just done something called rationalize the denominator. Another grade 11 skill that we taught you. 1 over root 3 has a radical in the bottom. We don't like to work with radicals in the bottom, and when I show you the unit circle values, you'll see why it's more purposeful to not use a radical in the bottom. So how do we get rid of that? We multiply top and bottom by root 3, because that's really just equal to the number 1 and doesn't change the value. And we get a root 3 on top, and root 3 times itself is the same as 3. If you put these two values in your calculator, you will get the same decimal. They are the same number. We just prefer to not have radical signs in denominators. That's all that's happened there. Now there was a typo on this. You can see that I've crossed off in the last column here. Sine was the only thing that was written, but it's sine, cosine, and tangent. 45 is an isosceles triangle where two sides are the same. So we made those two sides 1, and then we did Pythagorean theorem to find the root 2. And here are the special triangle values for this triangle. Now, the reason why we use these is because 30, 60, and 45 are the three values that you need to know to basically draw the entire unit circle. So here's that unit circle that I wanted you to draw with your Lysol bottle. Like, make it take up an entire page of blank white paper or loose leaf paper, it doesn't matter. Get out a ruler, draw your lines straight, and get this as neat as you can, because you will be using this for the whole unit. Okay, maybe do a rough copy and then do a good copy, and make sure that it's very clear and you have lots of detail on it. So the first thing I want to start with is the angle measurements. We start at the positive x-axis, and this is a 0 degrees. Then we hit 90, 180, and 270. And we come all the way back around to 360. And we could keep going, but if we know everything for one circle, we can figure things out for other coterminal angles. Now, next thing to figure out is, remember that this circle is made from all of these ordered pairs on the outside of a radius of 1. So remember, the radius here is 1 unit. I'm not going to leave that on there because I need room to draw everything, but that's where these points are coming from. So if I went from the origin 1 unit to the right, what point have I ended up at? It's an x-intercept, so the y value is 0. This is the point 1, 0. Similarly, if I go to the point on the y-axis, up here, I have 0, 1. What changes if I go to the negative x-axis? That's exactly right. The x is negative. What changes down here is that the y is negative. But you can see that all of these are a value of 1 because it's the unit circle with a radius of 1. Now, those are useful points. The rest of the points look a little bit scary, I'm not going to lie, because they have a whole bunch of square roots and fractions. But don't be too worried. These are actually a lot easier to work with than it looks like. The first thing I want us to draw, and you can use a different color if you want, is a 30-degree angle. Now at 30 degrees, if we refer to the previous slide of special triangles, remember that your ordered pairs tell you cosine and then sine. That's your x, comma, y. So if I go to the previous slide and figure out what cosine of 30 degrees is, it's root 3 over 2. Sine of 30 degrees is 1 over 2. Now I'm going to show you how we really don't need to know any of the other quadrants. We only need to know quadrant 1, because if you imagine this green line being reflected, like we did in Unit 1, over the y-axis into quadrant 2, what's the only thing that would change? The y value is still the same, but the x value is now negative. So the numbers are still the same, but you can see my x value is negative. What would happen if I then took that point and I flipped it over the x-axis? The x value doesn't change, but the y value is now negative. This is how we reproduce the entire unit circle, knowing only 3 values. If I flip my original 30 degrees over the y-axis, I'm going to have a positive x value in quadrant 4 and a negative y value. Now we need to do the same thing with 45 degrees and 60 degrees, and then we will have reproduced the entire unit circle. 45 is next. 45 degrees, if you look on your last slide, is going to have a cosine of root 2 over 2 and a sine of root 2 over 2, the exact same thing. Put that in quadrant 2, and you don't even have to memorize this. Like, the same thing is happening that just happened with the 30 degrees. The x is negative, the y is positive. You just have to look at the Cartesian plane to determine what the signs are in that quadrant. They're always going to be, negative x and positive y. In quadrant 2, quadrant 1 is always going to be double positives. Quadrant 4 is a positive negative, and quadrant 3 is a negative negative. If you know those rules, it's really easy to produce all of these angles. You know it's the same numbers every time, and then you follow the sign rules according to the quadrant. Okay, one more angle. That's 60 degrees. 60 degrees, according to my previous page, has a cosine of 1/2. Remember, I'm working with this. And it has a sine of root 3 over 2. I'm now going to reproduce that in every other quadrant following the sine rules. Boom, done. That's the unit circle that you need to know. Now, what are all of these other colored lines in quadrant 2, 3, and 4 representing? Well, they're representing the original angles that we worked with as a reference angle. Okay, so this blue line that we just put in quadrant 2 here, let's draw this stuff, but I'm going to erase it. The blue line here has a reference angle that's the same reference angle as the first quadrant. It just so happens that in the first quadrant, the reference angle is the angle that we were working with. So in quadrant 2, the reference angle has a 60-degree reference angle. So you need to know how to calculate angles in quadrant 2. You're going to go 180 minus the reference angle. So 180 minus 60 gives me this blue line at 120 degrees. Same idea for the red line of 45. If I reflect it over, it's now 45 degrees away from 180. So 180 minus 45 is 135. The green one is 30 degrees away from 180. 180 minus 30 is 150. You can do this all the way around the circle, and I encourage you to try. It's a good test of how well you understood the first lesson, and you should get these numbers. There. We've got a complete circle now. We've got our angles written in degrees. That's okay. You'll see some of the more in-depth unit circles, including radians as well. But I trust that you're able to convert from degrees to radians rather easily now. And I have included all of the conversions below that we usually would go through in a lesson and do together, but you have already done that in lesson 1 and had lots of practice from the textbook. So make sure you're able to do that. And if not, you might want to practice some more with the unit circle and how they convert. Now, one thing that we learned in grade 11 was the CAST rule. Now, the CAST rule tells us in that specific quadrant what trig ratios are positive. So in quadrant 1, the A stands for all are positive. So you can see that both cosine and sine in all of our brackets were positives. In the second quadrant, sine is the only positive. So you can see that the y coordinate for all those points is positive because it represents sine theta, and the x coordinate is negative because it's cosine. In the third quadrant, tangent is the only positive ratio. Since the ordered pairs represent cosine and sine, both of them would be negative because tan's the only positive. And in quadrant 4, same idea for cosine being negative, everything else, or pardon me, cosine being positive, everything else being negative. So really, you don't have to memorize the entire unit circle. There's countless videos on YouTube that teach you different ways to memorize the entire unit circle, but I don't expect you to do that. I expect you to memorize one quadrant, be able to write it down at the beginning of a quiz or an exam from memory, and then I expect you to be able to do transformations like flipping it around into the other quadrants. That's all you need to know. So really what we're doing right now is completely erasing all 3 quadrants except for the first one. That's all you need to memorize. Now, I'm not going to leave it like that for the purpose of your notes, but this is really all you need to know. There you go. Don't freak out too quickly. Now, the first quadrant has a little trick. If you memorize this trick, you can recreate the first quadrant in a matter of seconds. I want to bring your attention now to the numerators. What do you notice as I highlight these numerators is happening to the numbers? 3, 2, 1, 3, 2, 1. Now they're all under radical signs, and you might be thinking the 1 isn't under a radical sign, but what is the square root of 1? 1. So it really could be under a radical sign. It's the same number either way. So all of the numerators you can think of having a radical sign. Starting with 30 degrees, you start with a radical with 3, 2, 1, 3, 2, 1. That's really all you have to know, because what do you notice about the denominators? Every single one is a 2. This is why rationalizing the denominator is a big help to us, because it made all the denominators the same number. That makes memorizing this unit circle easy peasy. So 3, 2, 1, 3, 2, 1. You go up the circle and back down, and then all the denominators are 2. All the numerators have a radical sign, and we know square root 1 is 1, so write it or don't write it, it doesn't matter. And then you can flip each of those lines into the other quadrants to find different angles. Now that we know all of this information on the unit circle, how does it get used? So the way that we use the unit circle is to answer questions like this algebraically. Sure, you can put this in your calculator and get a decimal, but that's not going to get you any marks in 30-1. Tan 45, you should be able to figure out as an exact value without touching your calculator. So what I want you to do is go to 45 degrees on the unit circle. So bring your paper back out, go to 45 degrees. You should see that 45 degrees is the ordered pair root 2 over 2, comma, root 2 over 2. And let me remind you that these ordered pairs are always telling you cosine is the first thing, or let me put 45 degrees in there because we actually know what it is. Oh my. Okay, and sine 45 degrees. That's what the ordered pair on the unit circle is telling you at 45 degrees. That cosine 45 is root 2 over 2, and sine 45 is root 2 over 2. If you don't quite believe me, put one of them in your calculator and then put root 2 over 2 in your calculator. You'll get the same decimals, which reminds me that there's another method of memorizing the unit circle, which involves just knowing the decimals. If you put all of those numbers in your calculator, you'll start to recognize 0.886 or something like that keeps coming up over and over and over again. Some of these decimal values you'll start to recognize are values from the unit circle. Now, tan 45 is on our formula sheet. If we look up tan theta, it's equal to sine theta over cos theta. Okay, that's on your formula sheet. Now, we're working with 45 degrees for theta. And I'm also going to sub in what sine theta is equal to, or sine 45 is equal to. Sine 45 is equal to the second coordinate on the unit circle at 45, which is root 2 over 2. Cosine 45 equal to the first. They just so happen to be the same because of the special 45 triangle. And when you take two things in math and divide exactly the same thing, what number do you get? Big ol' 1. So try it. Put tan 45 in your calculator. You should get the number 1. Let's try again. Tan of 240 degrees now. Now, if this was a question and we only had the first quadrant of the unit circle, we would have to reflect until we got an angle of 240. Or we can think about 240. It's down in quadrant 3. It's going to have a reference angle that's 240 minus 180. So it's going to have a reference angle of 60 degrees. So again, this is sine 240 over cos 240. At 60 degrees, what is my point on the unit circle? Well, in quadrant 1, remember the numerators went 3, 2, 1. So it's 1 over 2, root 3 over 2. But that's in quadrant 1. We aren't working in quadrant 1. 240 is in quadrant 3. What are the signs in quadrant 3? Negative, negative. So we have to put in negative root 3 over 2 and negative 1/2. Remember, this one is cosine and this one is sine. It's alphabetical order. That's how I remember it. CS. Okay, fractions with radicals. If you try putting this in your calculator, it's way harder to get all of the brackets right than it is just to do the math by hand. When I'm dividing fractions, I write them vertically like this, first of all. So negative root 3 over 2, divide negative 1/2. Then I remember from grade 7 that division of a fraction is multiplication of the reciprocal. So I change it to multiply. I flip the second guy. I notice that 2 negatives will cancel. I notice that a 2 on top and bottom will cancel. And I end up with the value of root 3. Now, to check this in your calculator, I should mention that this is in degrees. So you would have to be in degree mode in your calculator. If we do the next two questions that are in radians, you will have to switch to radian mode to get the right answer. So in Math 30-1, we do a lot of switching between degree and radians. That should always be something that you're thinking about with the question. All right, tan of pi. Still, tangent is sine over cosine. And pi is 180 degrees. A full circle is 2 pi, so half a circle is pi. Okay, we have a point right at 180 degrees. I'm just going to go back for a second. Here's that point at 180 degrees. It's the point -1, 0. So if I just write that over here, remember alphabetical order, cosine, sine. So if I fill this in, sine pi is the number 0, cosine pi is the number -1. Now you really need to think, is this something that we're allowed to do, 0 divided by -1? Absolutely. If I give you 0 Skittles, can you put them into one group? Sure you can. There's 0 in each group. If you don't believe me, check on your calculator. It won't give you an error. It will tell you that 0 divided by -1 is 0. It's fine. The thing that we cannot do in math, remember, is have a 0 on the bottom. So let's try tan of pi over 2. If pi from the last question was 180 degrees, and this is half of pi, what's half of 180 degrees? 90 degrees. What is the point on the unit circle that's 1 unit away from the origin on the positive y-axis at 90 degrees, or pi by 2? Well, that would be 0 in the x direction and 1 in the y direction. This is sine of pi by 2 over cosine of pi by 2 according to the formula sheet. This is going to be cosine sine 1 over 0. We just talked about this. I can't give you one Skittle and you divide it into 0 groups because you have one Skittle. So we have to write the appropriate word. We can't just stop there. You need to communicate with the person that's reading your work that you know that this gives you an error on your calculator. What is the word that tells the reader that this is not allowed in math? Undefined. This is a number that's undefined. You can also say non-real answer, but I like undefined. It's one word, simple, easy to remember. Now, if you'd like to skip ahead here, I'm going to show you exactly why tangent is equal to sine over cosine. We've been using that from the formula sheet, so I just want to clear up why exactly that's on the formula sheet. Okay, so let's do this with good old SOHCAHTOA. We're saying that tan theta is equal to sine over cosine. Well, sine, according to SOHCAHTOA, is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Let's do this by dividing fractions. Divided by the bottom. Let's leave the first fraction. Let's change to multiply and flip the second guy. Aha, you might be seeing what's happening here. Top and bottom hypes will cancel. You're left with opposite on the top and adjacent on the bottom. Is tan theta equal to opposite over adjacent? Yes. All along in grade 10 and 11, this is secretly what was happening. We just didn't tell you about it. So sine divided by cosine is always going to give you tangent. Here we go. Do the following points exist on the unit circle? Now, I'm going to give you a very rough proof. I'm going to put it in quotations because it's not technically a proof, but I'm going to set it up like a proof because that's what we're looking to do at the end of our trig unit. We're trying to get to the point where we can start doing proofs. And if you take higher level mathematics at university, this is a main thing that we do, is we try and prove or disprove certain things. Now, we want to say, do these exist on the unit circle? Well, the unit circle is this equation. So if I sub this point in and it gives me something that's a mathematical lie, then it doesn't exist on the unit circle. If I sub it in and everything works out peachy keen, then it does exist on the unit circle. The way that I'm going to prove this is by setting up what we call a T-chart or a T-proof. I'm going to make kind of a T shape. See that? The vertical part of the T is just going through the equal sign. It represents the equal sign so that I don't have to keep writing the equal sign every single time. So I'm going to sub in my X value and my Y value. And I'm going to write the 1 that's in the right-hand column, but in a proof, you don't have to keep writing the same thing over and over again. That column is equal to 1, and it's going to stay that way till the end of the proof. Unlike algebra, nothing gets moved from side to side. Nothing is crossing the equal sign. That's why we set up this T. This T shape helps you keep the left side and the right side separate, and all you're doing is evaluating. So on the left side, I've got a lot of work to do. On the right side, it's equal to number 1. I don't have to do anything on the right side ever again. Let's evaluate. So let's just keep going until we get down to a final number on the left-hand side. 1 squared and 2 squared. 1 over 4. These brackets that I drew were extremely important. If you didn't put the brackets, you might get a sign error, because when you take negative root 3 and you square it, a negative times a negative is a positive. If you didn't have that bracket there, you would have kept your answer as a negative, which is wrong. Now, square root and squared cancel, so this ends up being positive 3, and on the bottom, 2 squared is 4. How do I add fractions now? 1/4 plus 3/4. Add the tops. 1 plus 3 is 4. The common denominator stays the same. And 4 divided by 4 is the number 1. So what I have is I have 1 on the left side and 1 on the right side. When you do a proof, you have to give a quick little sentence at the end, kind of summing up what you've decided. So I have decided that left side equals right side. Therefore, that's what the 3 little dots mean. Therefore, P, my point that I was working with, is a point on the unit circle. The math worked out. I got one side to be 1, the other side to be 1. It's kind of like when we verify stuff. So I can conclude that what I was trying to show was true. The point P is a point on the unit circle. Let's see what we get for part B. Here's the unit circle. I'm going to draw my T-chart with my vertical line right under the equal sign. I'm going to sub my point in brackets because I want to square everything. I'm done on the right side because it's already evaluated down to a single number. Now 3 squared is 9 and 4 squared is 16. I need to make a common denominator next. I'm going to times top and bottom here by 4 to get a common denominator of 16. I'm going to add my numerators since I have a common denominator. And what have I got? 13 over 16 is equal to 1. Is that true? Absolutely not. I've got left side not equal to right side. Therefore, the point, what can I say about the point? It is not on the unit circle. Okay, we got something that wasn't true. So what we were trying to show in the beginning was not true. So again, not technically proofs, but set up in a similar way so you can start thinking less about algebra and moving things from one side to the other, and more about showing things to be true in a proof T-column kind of way. Last question. The point 5, 6, comma, y is on the unit circle. What are the value or values of y? In the question itself, there is a huge hint. We're saying this is either singular or plural. That means that there could be one answer or possibly two answers. That means when we do the algebra, we really need to think about whether we can have two answers from this. So let's think about that as we try and sub this into our equation. Now, I'm not trying to prove that some point is on the unit circle because I don't actually have the point. I don't know what y is. I'm trying to find y. This is classic algebra. Algebra is when you want to try and find a missing value. If that's what we're doing, we're not doing a proof in this question. You're not setting up a T-chart. You're subbing in your x and your y, which we don't know, and you're going to move everything to one side of the equation so that you can figure out what y is. So you need to understand the difference. Algebra, you want to find something that's missing. With a proof, you have an answer. You want to see if it's right or not. Now, 5 squared and 6 squared, 25 and 36. I'm going to isolate y squared now by subtracting this term that's adding to it. Now, the best way to work with fractions is in your head. If I'm trying to go 1 minus something over 36, I'm going to make 1 a denominator of 36. So I'm going to make the number 1 36 over 36, and then I can minus 25 over 36. So 36 minus 25 is 9 over the common denominator of 36. Or pardon me, it's 11 over 36. Now, how do we get y by itself if it's being squared? The opposite of squaring is square rooting. And this is exactly where you should kind of be feeling like there could be two answers. Because when we square root something, we can get a positive or a negative answer. Usually we focus in on the principal square root, which is the positive answer. But technically, if you take 2 squared, you get 4. And if you take negative 2 squared, you also get 4. It comes from the positive and the negative. So y could be positive or negative root 11 over 6. I can't square root 11 nicely, but I can square root 36 nicely, so I've done that. So what this tells me, if I can get a positive or a negative, is that, what was this point? 5 over 6 comma y. So therefore, here's my x value, here's my positive y value, and with the same x value, I can have a negative y value, are the 2 points on the unit circle. Think about this. This is a circle. You have a point at positive 5/6, positive 11/6, somewhere here in quadrant 1. You also have a point at a positive x and a negative y, somewhere in quadrant 4. That's all this is saying, is that you've got 2 points that are both going to work on the unit circle. And it comes from that fact that when you square the negative y value, it becomes positive anyways, giving you the same numerical value. All right, here's the textbook work for this section. I can send you pictures of solutions if you're stuck with any of those, or if you want to video chat and do some of these examples together because you're struggling, by all means, just communicate that with me. Your mark in all of this is coming from your level of effort, your communication with me, and how well you're doing with the material. So you need to make sure that you're doing the communication piece as I keep asking you to. Okay, look forward to hearing from you soon.